Hey folks, this is Dr. Humston. Welcome to Lecture 1.5, Temperature Scales and Conversions. So this is going to wrap up Chapter 1 today, and I think we'll get through this one pretty quickly. So here we're focusing on a special kind of conversion, just temperatures. All right, so as you are probably familiar with, there are three temperature scales that are used in different contexts. So we have Fahrenheit, Celsius, and Kelvin. You probably know the first two. You may or may not know the third one, Kelvin, and we'll definitely get to that today and talk about why that shows up in science. A few things to point out. If you look at Fahrenheit and Celsius, they have the degree symbol, and Kelvin does not, just a capital K. All right, so Fahrenheit, degrees Celsius, Kelvin is how we would say it. And so these are all possible uses to report temperature um, for various, traditional reasons. We have them. Um, the Kelvin scale is the one that we use in science, and it's an absolute temperature scale. Okay, so more details about that coming up. So first, the one that we are familiar with probably here in America, right, is Fahrenheit. So when you have a beautiful day and it's 72 degrees outside, what we really mean is 72 degrees Fahrenheit, right? Or if you have a temperature nowadays, I think we are very aware of that. Um, it's like 100.4 degrees. Well, degrees what? Degrees Fahrenheit, of course, right? But also when it's cold, right? We can have negative degrees, right? It gets really cold and gets like 10 below zero. So it's a relative scale. It uses plus, uses minus. There's some arbitrary distinction where we have zero, and then we can go above and below that. Okay. Um, we use this for reporting weather, of course, in the United States. That's what we're familiar with. It is not used in the medical field in the United States. But as we've talked about, your patients are going to be much more familiar with Fahrenheit than anything else. So while you probably won't directly be measuring any temperatures in Fahrenheit, you may have to be thinking about um, conversions from something into Fahrenheit so you can communicate it. Okay, another scale that you might be less familiar with but you still know about would be Celsius. Um, so this is another relative scale, uses plus and minus, and it has a zero value, but zero here is not at the same temperature as zero in Fahrenheit, and the size of each step, like 1 degree Celsius, is not equal to 1 degree Fahrenheit. So it's really a very different temperature scale, other than the fact that it's a relative scale with pluses and minuses also. Now this is used worldwide for all temperature reporting, right? Everywhere else except here. And it's also often used to take body temperatures. Um, so we have this number in our minds probably of 98.6 degrees Fahrenheit, and we can talk about that in just a moment. Um, so that would be equivalent to 37 degrees Celsius. So that's like normal body temperature. Notice, so hypothermia is less than 35. So notice there's still 2 degrees difference between 35 and 37. So this 37 degrees and 98.6 are what you would say would be like a population average. Okay, individuals can have different normal body temperatures, right? You might have some person who runs slightly high, some person who runs slightly cool, and so it's important that um, like if you know that about yourself, right? And so if someone takes your temperature and thinks that you have a high temperature, you can say, well, actually that's normal for me, right? It might be above 98.6, but it's still normal for you. Um, so there's definitely a range to this number, but the agreed upon like average is 37 is about normal. Like we said, hypothermia, if you're too cold, would be body temperature less than 35, and heat stroke greater than 40 degrees C. So just to get some idea of what kinds of numbers we're talking about. And before we said, a nice beautiful day might be 72 degrees Fahrenheit, but you go to Europe and it's a beautiful day and you look at a clock and a temperature somewhere and it's 22 degrees. And you're like, what? 22 degrees? So that's approximately equivalent to 72 degrees Fahrenheit. So you can get some scale of these numbers. So in the typical kind of range that we're used to, that we live in, Celsius numbers are lower than Fahrenheit numbers. But we'll get to the exact conversion here shortly. And the next thing I want to do is talk about this third scale, which is Kelvin. So Kelvin is actually the SI unit for temperature. Remember the SI is the standard international, so the units we use in science. And it's an absolute scale, which means there are no negative values. It means that there is actually a 0 Kelvin is the absolute theoretical coldest possible. Temperature is a measurement of the average, what? Temperature is a measure of average kinetic energy. We learned that before. So, uh, in you could imagine average kinetic energy getting smaller and smaller and smaller, and it can't be negative. So at some point it's 0, and that's the coldest possible thing. We've never actually, you can't reach absolute 0, but scientists have gotten very, very close with cold um, to 0, like within fractions of a Kelvin. Um, and it's also used in problems related to gases. So anytime temperature appears in an equation, going from positive to negative would really mess up your equation. Um, but temperature Kelvin scale, right? It's 0 and positive, and that's it. And there's no negatives. So we'll see again how these all relate right now. Okay, so here is a figure from your textbook, but we might want to spend a little bit of time thinking about this and looking at this. So remember that a measure of temperature is what it is, right? You can change the units, but the thing you're measuring is not changing, right? It's like um, the desk that I'm sitting at has a length in space, whether I choose to measure it in inches or centimeters or fractions of a mile. It is what it is, and the same is here with temperature. We're just changing the numbers that appear beside it. So here, I like this. It's showing three thermometers all reading the same temperature, the same actual reality, but you see different numbers, right? So let's take a first look right here at normal human body temperature. And we can see that we saw this before, 98.6 degrees Fahrenheit would equal 37 degrees Celsius, and it would equal 310 Kelvin. Now, some really easy and kind of clear uh, other points are the freezing and boiling point of water, right? So all of us in America know that water freezes at 32 degrees. Um, that's when water turns to ice and we get snow, and that's equivalent to 0 degrees Celsius, but also 273 Kelvin. At the high end, water boils at 212 degrees Fahrenheit, 100 degrees Celsius, and 373 Kelvin. So now let's look at the increments between freezing and boiling. And in Fahrenheit, these numbers seem kind of random, right? And they kind of are, to be honest. So between freezing at 32 and boiling at 212, we have 180 degrees. So 180 steps between these two differences. In Celsius, man, Celsius, just like the metric system, it makes a lot more sense. So freezing is 0, boiling is 100, and so everything, liquid water, exists. There's 100 steps in between freezing and boiling. And so sometimes you'll hear Celsius also called centigrade, where that cent, right, is like 100. So there's 100 gradients between freezing and boiling. So you see that even the step size between Celsius and Fahrenheit is different. Now, the step size of Kelvin, even though the absolute values here are different, there are 100 steps between freezing and boiling, and there are 100 steps in Celsius between freezing and boiling. So like a change of 10 degrees Celsius is also a change of 10 Kelvin. So the step size of a Celsius degree is the same as the step of a Kelvin. All right. So just like this alone would be enough to devise a conversion, right? And I want to give you a chance to think about this for yourself for a moment. So at 0 Celsius, we have 32 Fahrenheit. So there's some offset, right? You have to have Fahrenheit is equal to Celsius plus 32 at 0, right? But then we have step size is different, right? So when you get up to Celsius being 100, so at C is 100, Fahrenheit would be 100 plus 32, but it's not 132, right? Because the step size is different. So you have to have a multiplying factor in there as well to account for the step size. So since we have 180 here and 100 here, right? If you've gone, let's just use these numbers. If you've gone 100 in Celsius, you've actually gone 180 in Fahrenheit. And so you've gone more steps. And you've gone 180 over 100, right? So it's which is equal to 1.8. And so however many steps you take in Celsius, you have to multiply by 1.8 to get the steps in Fahrenheit. So we can combine these ideas, and we can get the Fahrenheit is equal to whatever degrees Celsius times 1.8 plus 32. So we see if that works now. We'll put 100 degrees here times 1.8 is 180 plus 32 is 212. So that works. Remember, let's try 37. So body temperature, we take 37 times 1.8 plus 32, and that would equal 66.6 plus 32, which is 98.6, which is what we wanted. And still, if we plug in 0 times 1.8 is 0 plus 32, 32. So it seems to be working. So we just came up with a conversion between Celsius and Fahrenheit. Now, if you wanted to go the other direction, like let's say you have Fahrenheit and you want to get Celsius, you can work backwards and you'd end up with this right here, right? And I'll show you where that comes from. So remember we'll now use this notation, T in F is equal to TC times 1.8 plus 32. So if I subtract 32 from both sides, then I now have TF minus 32 is equal to TC times 1.8 and divide by 1.8 on both sides. So TC is TF minus 32 over 1.8, which is what we see here. Right, so we have a conversion from Celsius to Fahrenheit right here. We have a conversion from Fahrenheit to Celsius, and the conversion from between Celsius and Kelvin is very simple because the step sizes are the same. All we have is a offset factor. So we just add or subtract 273.15. So TC is TK minus 273, or we could say TK is TC plus 273, right? So if you're at 0 degrees Celsius, you're at 273 degrees Kelvin. Now, notice that we do not have an easy or single equation that connects Kelvin and Fahrenheit. So we have to go through Celsius. And that's actually okay because Celsius is the one that's most commonly used. So that works out well. Okay, this actually ended up being the longest video I've done yet. But let's stop here and we'll just have one more part. And in part 2, we'll just do some conversions and get some practice. All right, so I'll see you there.